Hello everyone, it's Mr. Wolf here, and in this video I'm going to be discussing video modeling scenario number 3, where a neutral person is going to touch a positively touched Van de Graaff generator on a box, and the question is, what's going to happen to their hair? Okay, so first let's talk about our objects. Right? We have a Van de Graaff generator, which is a conductor, which means electrons can move freely around the object. It's positively charged, which means that it has less electrons than protons. Specifically, it has a charge of positive H, which means I have 8 protons missing an electron. All right, since this is a conductor and electrons can move freely, these electrons are repelled from each other, and so they're kind of as far away from each other as possible, and so my charge is distributed evenly throughout the entire object. Right. Then I have my person, and my person is also a conductor. I'm going to make this person, or the Van de Graaff, positive. All right, the person is a conductor, which means electrons can move freely throughout the object. All right, but the person right now is charged neutral, which means they have an equal amount of protons and electrons, so they're neutral. And again, they are standing on a box, and the box is obviously on the ground. Okay, and it's an insulated box, like a plastic box. All right, so now the person is gonna put their hand on the Van de Graaff generator. All right, they might get a little shocked. But they're going to come into contact. And now we want to ask our question, which way are electrons going to move? Which is going to cause that shock? All right. Well, electrons in my neutral conductor are attracted to all these exposed electrons in my other conductor, the Van de Graaff generator. All right, so electrons are going to start jumping over to my Van de Graaff generator. All right, now, these electrons, once they're on the generator, since it's a conductor, they can freely move around the entire Van de Graaff. So maybe this electron is going to travel all the way over here, and this electron is going to travel all the way over here. Right? And remember, the person's also a conductor. So electrons can move freely throughout this object. So even though these electrons may not be really, really close to our Van de Graaff, they can move over to maybe this proton right here. And since, again, it's a conductor, electrons can move freely, maybe this one right here. Right? Now at this point, right, electrons are going to want to move to our exposed protons, but if you notice that we have 4 exposed protons here and 4 exposed protons here, so electrons really don't want to move one way or the other. Now, since again that my person's a conductor, these electrons are repelled from one another, right? So they're going to kind of move around until they can move as far away as possible from one another. So in both objects are going to end positive. Right? With the charge of positive 4, they each have 4 exposed protons right here. And notice for both objects, they're both conductors, so my charge is evenly distributed. Right? So now the question is, well, what's going to happen to this person's hair? Right? And what's important is that this person is standing on a box that's connected to the ground. If the box wasn't there, all right, then this would be an example of grounding. I could have electrons move to the person, and the person would become neutral, but because there's this insulated box, even though electrons may want to go from the ground of the person to ground them, they can't travel through this insulated box. So the charge that we see on the person and the Van de Graaff, it's kind of like our final charge. Right? And so if the person's positive, right, and since they're a conductor, that charge is evenly distributed, which means that their hair is also positive. And if they're tiny, each tiny hair has a positive charge, positive charges repel one another. And so to get as far away as possible from each other, the best thing that the hair could do is stand up, in this case, with that positive charge.